Hello everyone, my name is Vimal Raj. I'm a lecturer from James Polytechnic College, Department Mechanical. So today we're going to discuss on the unit number 2, that is ferrous metals and alloys. So this is a lecture number 5, and today we're going to discuss about the characteristics and applications of ferrous metal. So the content that we're going to discuss today is characteristics and application of ferrous metal. Ferrous metal definition. So these are the metals which contain iron. So they may have small amount of other metals or other elements added to give the required properties. That means ferrous metal is basically a metal where which the composition would be mostly iron and only a little bit of other elements will be present. So that is called the ferrous metal. So all ferrous metals are magnetic and give little resistance to corrosion. That means all the ferrous metal have this magnetic effect. So that means if you place these ferrous metal near to a magnet, it will attract. So basically whichever the metal that gives, that has been attracted to magnet, that is called the ferrous metal. So ferrous metal, if suppose any metal you come across, if it's having a magnetic field, or else if it has a magnetic property, then it is clearly a ferrous metal. So specific type would be, these are the types that could be available, that is wrought iron, cast iron, pig iron, carbon steel, low alloy steel, stainless steel, and tool steel, among others. So iron is classified as wrought or cast iron. The wrought iron contains less than 0.2% of carbon. Basically these wrought iron have only minimum of only 0.2% of carbon which will be present, and the cast iron will be having 2 to 4% of carbon, and the carbon content between 0.2 to 2% is classified as steel. So basically if the carbon content which is present in between 0.2 to 2% is considered as a steel. So these are the physical characteristics of iron. So iron is heavy and a soft material that is relatively easy to form hot or cold. Iron has a high thermal conductivity. So basically iron is a heavy or a soft material that is relatively which is having hot or cold. Basically this iron material and all, they can easily they are good conductor of electricity. They are good conductor of heat and cold. Basically when you see any of the iron materials which is in the cold region, see in some videos on YouTube videos and all, we would have seen it. The iron object which is placed in the Antarctica or the area where in which the temperature goes below zero, people will go and place their tongue in the iron, and after that what happens is the tongue will be sticking, that will be sticked to the lamppost or the thing. That shows the iron has a it's very relatively easy for, it is very easy to attract the cold, as well as iron is also relatively forms hot also, because that's the reason this iron can absorb heat very much, and this has a thermal conductivity. So basically thermal conductivity is nothing but that it acts as a bridge between the object, in which if heat is applied on the particular material, the heat can be transferred to the other end. That's the reason pan and all, see, we use pan to make cook food and all, right? So fire is there at the bottom of the stove, and in between the pan has been placed, on the top food will be placed. So this heat is not directly passed to the food, Instead of that, it has been passing over the pan, and the pan will give the heat so that the food is cooked and ready. Next one is iron ore is an abundant material in the earth's crust, and when mined can fall into a number of types: gray, yellow, purple and red. So no matter the color of the ore, the mineral is known to be both heavy and soft. So it is fairly easy mineral to form using all the hot or cold press. So basically this is a iron ore is abundant material in the earth's crust. So basically in our soil region, iron content can be found out easily. So wrought iron has a very low carbon content and very few contaminants. Cast iron is made up of iron, carbon, and small amount of silicon. So these are different types, including gray, white, ductile, and malleable. So we all know what is ductile, malleable, all those things, right? So if suppose anybody doesn't know the meaning for ductile, malleable, and all, you can see the previous video. I would have explained it clearly. So they are the differentiated by the formation of carbon in the iron matrix and alloying elements, very strong but brittle. So melting point could be 1535 degrees Celsius, making it decently easy to melt down. So that's the melting point of iron. Next on the typical applications. So wrought iron has been largely replaced by steel. So basically this iron has been largely replaced by steel. Traditionally, applications include architectural metalworks and fencing. So we could have seen the fencing and all everywhere. So these fencing is nothing but which is made by this wrought iron, and it remains a useful material in a constructive industry, wherein which these tools and automatic crankshaft and suspensions, arms, and also for cooking equipments due to its high thermal conductivity. So even for the cooking also, for making this cooking equipment also, they use this wrought iron. So cast iron, traditional structural material, hardware, stairs, decorative features, fence, tools, utensils, and straws used to manufacture items such as engine blocks and manhole cover. So these are the cast iron. So manhole cover, maybe in the upcoming video I will show you what is manhole cover. Manhole cover is nothing but the drainage system and all. There is a cover on the top of all the drainage hooks, right? So that's called the manhole cover. So cast iron is being used in the structural material. So traditional structural material, they used this cast iron. And wrought iron traditionally used as an inexpensive structural material for fencing. So fencing, we all know what is fencing, right? That's a barricade wherein which every house or agricultural land, all they put the fencing. So this fencing and automotive crankshaft, suspension arms, and cooking equipments has fallen out of use somewhat. So this is a phase equilibrium diagram for iron and carbide. So you could see the temperature and composition. This is a flow diagram for production of iron and steel. So that is the iron making process. I will show you with the laser. So this is the iron making process, and this is the steel making process. So basically how the process happens is iron ore has been taken and it is been molten heated, which is been then go to the blast furnace slag. So then it is go to air cooled blast furnace slag. Once this molten when it's melted, it goes to the another area in which with the help of this flux scopes ferrous alloy, it is been again sent into the another area, that is basic oxygen furnace. So here it has been treated, and after that it again goes as a molten steel, in which some amount of carbon will be added. That is the 0.2%. I mean, some percentage is there, right? 0.2% to 2%. Sorry, 1.2% to 2% is classified as steel, right? So much of they will had carbon they will have after it goes to the process. So this is the flow diagram for the production of iron and iron carbide. Next one is the classification, composition and use of cast iron. So cast iron product of the blast furnace, i.e. pig iron, is unsuitable for casting as it contains impurities in high percentage to render it suitable for desired purpose. It is refined in the furnace known as cupola. So the refined product is termed as cast iron. Cast iron is a group of iron carbon alloy with a carbon content greater than 2%. So it is made by remelting pig iron. This is how the classification is happening. You could see that. Basically, what happens is this product is being first when there's a blast furnace, so that it is being melted, then which it contains some impurities on high percentage. So this is when the impurities will be removed. So to render it, they use it in a furnace called as cupola. So they will send this molten iron to this cupola so that all those impurities will be rendered and will be removed. So the redefined product is termed as cast iron. The cast iron may be classified as, first one is grey cast iron, white cast iron, malted cast iron, nodular cast iron, malleable cast iron, and the next one is the alloy cast iron. First one is the alloy cast iron we're going to see. So the cast iron is supposed to be very hard, brittle, lacking in tensile and transfer strength, and weak to withstand shocks. So it is alloyed with other metals to improve its properties. So amongst the alloying metal, nickel is predominating alloying constituent whose addition to the extent of 0.5% to 1.5% avoids the tendency of chilling or hot spot. So this alloy cast iron is very hard. It is brittle, hard and brittle. That means brittle means it can break. That is, like, you know what the brittle means. Glass has this brittle property, whereas if you put the glass down, the glass will break up, right? So this is the example of cast iron, which you can see it. I mean, there's a picture. So basically, these cast irons is alloying metal, where in which nickel is predominantly the alloying constituents. I mean, the nickel will be the predominant content will be used in the alloying, where in which it could extend up to 0.5% to 1.5% to avoid the tendency of chilling or hot spots. Composition of alloy cast iron. So alloy cast iron falls into two groups: those that contains graphite and those that do not, and both are designated white iron. So basically both these two things are designated as a white iron. So these are detailed in the below table. As with steel, any of these alloys containing oxide forming elements such as chromium added to promote corrosion resistance give more problem on casting. As a result of the surface oxide formation, the high nickel heat resistant cast irons nickel resistance however are relatively easy to cast and certainly much easier to cast than the equivalent heat resistant steel alloys. So basically these are formed into two groups, that is contains graphite and which does not contain graphite. So graphite free and graphite bearing. So you could see the flow chart how it is happening. So here it has the wear resistance, there it is having a corrosion and heat resistance. So the material which is having the graphite is good in corrosion and heat resistance, but the material which is not having the graphite is good in wear resistance, wear and corrosion, and other thing is also there, that the ferritic white iron is having a wear resistance, and high chromium ions will be having both wear, corrosion and heat resistance. So these are the classifications. See, the high nickel, high resistant cast iron, however, are relatively easy to cast. So casting is very easy on these materials. The properties of cast iron: high operating temperature. So you can use this material for a high operating temperature. That means you can use this material wherein which if the work has to be done with the high temperature, means you can operate this metal with those high temperature works. Outstanding corrosion resistance, that means this is very good in corrosion, so that it will not corrode with the, it will not have this corrosive property, so that it will not be corroded easily. And which is lightweight, that's a good sign, because always iron has a maximum weight wherein which it is very hard to carry, but wherein which this having a alloy cast iron having a mixture of carbon properties, right? So because of that, it is a lightweight and very good strength and hardness. So basically it is having lightweightness as well as it is having a good strength and hardness. So good stiffness and strength to weight ratio also is there. Excellent thermal conductivity. Is there. Basically it's having good thermal conductivity, so it can act as a conductor of heat. That's a good sign. So high electrical conductivity, so it means it can conduct electricity as well as, so it can be a bridge for electricity, and it is having a good finishing characteristics. Full recyclability, so that means even if you make a particular product with that, again you can remelt it and you can again cast it as a shape you want. So that is something which is a good sign. So recyclability is very important in all the materials, because recycling is very good, because even though after you make a product, simply we can melt it and we can reuse it. I mean, we can make it as a different product based on the requirements. Next one is the use of alloy cast iron. So it is used in making pipes to carry suitable fluids. Basically these alloy cast irons are been can be made as a pipe to carry fuels, I mean to carry suitable fluids. The pipes and all we always used to see, where in which some petrol, those things and all they used to transport from one area to another area, right? So with that they can do it. So it is used in making a different machines. So alloy cast iron can be used for making different machines. So it is used in making automotive parts. So automotive parts, we all know that cars, bikes, so many automotive things are there. So we can use that. I mean, we can make those automotive parts with the alloy cast iron. So it is used in making pots, pans, and utensils. So basically, it can be used in making pots and utensils. That means in cooking utensils, we can make use of this cast iron. So it is used in making anchor for ships. So the anchor that is used to stop the ship, right? With this cast iron, they can make the anchors for the ship. So that much hardness as well as that much durability is there with the alloy cast iron. So with that, we have come to the summary of the video. So discussed about the characteristic and application of ferrous metal. So these are the reference book. So if you want, you can just verify it. With this, we're completing this section number 5. So the next topic will be covered with the next unit. Thank you guys.